Tonight we're going to be talking about covalent bonds, and what the word I want you to think when you think covalent bonds is sharing. And you don't have to write this, but I do want you to listen. Here we have, if you look at the picture, we have two atoms of hydrogen. Hydrogen has one electron in its outer energy level, and it only has one energy level, so that's our couples level. So we only need two electrons to be happy. And you notice that hydrogen is one away from being happy or stable. And in this picture, they are near each other. So when two hydrogen atoms get near each other in the hypothetical world where they're not bonded together, what happens is the electron in one hydrogen atom is attracted to the proton in the other, and vice versa occurs. Remember I said that electrons are very unfaithful subatomic particles. They like to cause problems or make things better. So the electron is attracted to the proton in the other atom, but it's also attracted to the proton in its own atom. So it doesn't completely leave its atom, but it attracts the two atoms together. And part of atoms' goal, especially when they're unstable and reactive, is to be stable. So the two atoms are attracted to each other because their electrons in the outer energy levels are attracted to the protons in the other atoms. They come together, and what they actually do is they share electrons, as you can see here in this Venn diagram looking thing. So they're sharing electrons, and now this hydrogen atom here has two electrons, and this hydrogen atom here has two electrons. So they both are happy and stable atoms. So covalent bonds are the chemical bond that forms between non-metal atoms. That's key. They're two non-metals when they share electrons. And this just reiterates what I said. Two atoms get close enough to each other. The electron from each atom is attracted to the proton in the other atom. Not strong enough to pull the electron completely away from its proton, but are strong enough to bring the two atoms together to the point where they are able to share electrons. As you saw in the picture before. In order for this to happen, there needs to be attraction. Obviously, the electron in the one atom needs to be attracted, or it could be multiple electrons, needs to be attracted to the protons in the other atom. And second, remember how I said that if we think of an atom like an auditorium with seats, the first row is the couples row, only two electrons fit in it. The second row is 8 electrons to be full. The third row can hold more than 8 electrons, but it only needs 8 electrons to reach the occupancy limit for that row before you can move on to the next. So you always need 8 electrons before you can move on to the next, unless you're the couples row. So if there's room, you're going to put electrons there. So that's the second requirement, is there needs to be room in the outer energy level of both atoms. They both need that extra electron in order to be stable, in order to have that 8 electrons, or the 2 electrons if it's hydrogen. And as I said before, this hydrogen, two hydrogens bonding is the fact that they get near each other and then they bond is kind of hypothetical because hydrogen, this is an atom, it's a molecule. The hydrogen molecule is more stable than individual atoms because the electrons are closer to more protons, so they are happy. And in real life, hydrogen doesn't really exist naturally without being bonded to another hydrogen atom. So you will always see hydrogen, or not see, but you will always, hydrogen molecules will almost always be bonded together in the natural world, because that's what makes them stable or happy. And once the outer energy level is full, atoms are done bonding covalently, And they're not going to add any more atoms to the mix. They're going to stay, once they're happy, once they're stable, they are good to go. They don't want to add another atom because that will actually make them unstable again. Atom's life goal is to be stable. But they will continue to do so until they are completely full. And this happens because, and you don't have to write what's in the box here, but this happens because an electron from the new atom would have to join the other atom on the next energy level. So you would actually have to add an energy level for this to happen. And so the farther away you go from the nucleus, the more energy levels away you are, the less attraction there is between that electron and the positive nucleus. And an electron in the already bonded molecule is close to the nucleus and would not need to move farther away to share with the new atom. So it's unlikely that once they're bonded, they're stable, they're close as possible as they possibly can be to the nucleus. They aren't going to move away from it.